When discussing the history of American military aviation, two names always stand out when mentioning the era of fifth-generation stealth fighters, the F-22 Raptor and the YF-23 Black Widow. While the former became the public face of American air superiority, the latter, the YF-23, has remained a mystery for decades, shrouded in rumors, declassified documents, and the fascination of aviation experts. What few know is that this experimental aircraft, designed by Northrop in collaboration with McDonnell Douglas, represents a type of innovation that, if revived or incorporated into modern projects, could radically change the landscape of aerial warfare. If you're passionate about military aviation and want to learn the best-kept secrets of the most advanced fighter jets, like this post and turn on notifications so you don't miss anything. The YF-23 emerged as part of the Advanced Tactical Fighter Program, launched in the 1980s to develop a replacement for the then-aging F-15 Eagle. The program's objective was ambitious: to create an air superiority fighter capable of combining stealth, speed, maneuverability, and flight endurance at unprecedented levels. Northrop competed directly against Lockheed, which would present what would become the F-2002. From the outset, the YF-23 stood out for its radical design, diamond-shaped wings, an angular fuselage, and a structure that prioritized radar cross-section over extreme maneuverability. Its futuristic appearance reflected advanced thinking in aerodynamics and stealth, capable of evading the most sophisticated radars of the time. One of the most striking aspects of the YF-23 was its propulsion. The two prototypes, built known as Black Widow 2 inches and Grey Ghost, were equipped with Pratt & Whitney F119 PW100 engines, the same ones developed for the F-22, but with specific modifications to explore different combinations of speed and efficiency at altitude. The engine design, combined with the fuselage and the strategic placement of the nozzles, allowed the aircraft to reach speeds exceeding Mach 2 and extreme altitudes, while maintaining a much lower radar profile than any other aircraft of its generation. In fact, many experts consider the YF-23 to have been faster and stealthier than the F-22 in initial tests, although its close-quarters combat maneuverability lagged somewhat behind. The Advanced Tactical Fighter Program was shrouded in secrecy. Test flights were conducted at highly restricted bases, and the images available today come primarily from photographs released after decades of partial declassification. What is known is that the YF-23 impressed evaluators with its speed, fuel efficiency, and stealth capabilities. However, despite its advantages, Lockheed won the contract for mass production with the F-22, mainly due to its superior maneuverability in close-range air combat and political and strategic considerations by the Department of Defense. Since then, the YF-23 has remained relegated to test hangars and the imaginations of military analysts. What's fascinating is that although the program officially ended in the 1990s, the YF-23 never truly disappeared. Leaked documents and testimonies from former Northrop engineers reveal that some prototypes were preserved in secret facilities and that engineers continued to develop technologies derived from this aircraft. These technologies include improvements in ultralight composite materials, low detectability airframes, and advanced airflow control techniques to reduce the aircraft's infrared signature. Even today, many believe that the YF-23's concepts could have been integrated into experimental sixth-generation prototypes intended to redefine air superiority without relying solely on traditional maneuverability. A recurring point of discussion among experts is the military potential of the YF-23 if it were retrofitted with modern technology. With advanced AESA radar systems, AI integration for piloting assistance, and state-of-the-art weapons, the YF-23 could outperform the F-22 and F-35 in several critical metrics: speed, range, radar evasion, and the ability to operate in air defense-saturated environments. Some analysts even suggest that Northrop might be leveraging its legacy to develop a more advanced sixth-generation fighter, taking the best of the original design and applying decades of expertise in stealth and avionics. This has led to rumors that the return of the YF-23 is not just a nostalgic project, but a covert strategy to maintain its leading position in global military aviation. The story of the YF-23 is also shrouded in mystery and speculation. For years, some engineers leaked details about night flights conducted at maximum speeds at extreme altitudes, supposedly to test its behavior against enemy radar. Others mention experiments with next-generation sensors capable of tracking long-range missiles before they were detected. Although many of these accounts are not officially confirmed, the consistency of the testimonies suggests that the YF-23 was not just a failed experiment, but a high-level test platform that provided invaluable information to the Air Force and defense contractors. One technical aspect that distinguishes the YF-23 is its wing and tail design. Unlike the F-22, which uses conventional vertical stabilizers, the YF-23 employs inverted V-shaped control surfaces called V-rudders, which contribute to its low radar profile and improve efficiency at high speeds. This design, while less maneuverable in close combat, reduces drag and allows for evasive maneuvers that an enemy might find unpredictable. For long-range interception missions or penetration of advanced air defenses, this feature would have given American pilots a significant strategic advantage. Furthermore, the YF-23 was designed to operate in conjunction with advanced combat systems. Its avionics and sensors, while primitive compared to today's technology, were designed to interoperate with other aircraft and air defense networks. This suggests that Northrop and the Air Force viewed the YF-23 not only as an individual fighter, but as a node within a broader air warfare system capable of coordinating attacks and defenses at the theater level. In practical terms, this would have extended its survivability in intensive combat scenarios, allowing a single YF-23 to influence the dynamics of a large-scale air conflict. Tell us in the comments which aircraft you think will dominate the skies in the next decade, the F-35, the F-22, or a possible return of the YF-23. Although the program was officially cancelled in favor of the F-22 Raptor, the experience gained with the YF-23 was not lost. Engineers at Northrop and McDonnell Douglas continued to study its design, engines and avionics systems, applying that knowledge to new experimental projects and prototypes that have remained classified for decades. Many of these developments revolve around combining extreme speed, advanced stealth and AI-assisted flight control capabilities, areas in which the YF-23 had already set a precedent. One of the most fascinating aspects of this aircraft is its stealth capabilities. The angled fuselage, inverted V-shaped control surfaces, and the integration of the engines within the aircraft body significantly reduced its radar signature. In modern combat scenarios, where air defense systems utilize long-range radars and electro-optical sensors, these characteristics are essential. Defense specialists believe that if the YF-23 concept were revisited using more advanced composite materials and current stealth coatings, an aircraft of this type could operate in highly saturated environments undetected until it is too close to neutralize strategic targets. Another aspect that continues to attract the attention of military analysts is the relationship between speed and maneuverability. The YF-23 was designed to reach speeds exceeding Mach 2, allowing it to intercept targets before they could react, a critical factor in long-range engagements. Its close-quarters maneuverability was less than that of the F-22, but engineers argued that future air combat would focus more on long-range interception and neutralizing threats before engaging in direct confrontation. This philosophy, viewed today, anticipates the transition to sixth-generation fighters, where stealth, advanced sensor systems, and air network warfare prevail over traditional aerobatics. The YF-23's engines are also a separate chapter. Designed for efficiency and speed, these engines combined power with advanced airflow control, enabling sustained flight at high altitudes with relatively low fuel consumption. This detail is crucial because modern fighters seek to extend their range without relying on constant refueling, something the YF-23 had already been exploring for decades. Furthermore, studies of airflow and thermal signature reduction have served as a basis for improving the ability of next-generation aircraft to evade infrared sensors and heat-guided missiles. In terms of avionics and control systems, the YF-23 pioneered the integration of advanced flight computers that assisted the pilot in complex maneuvers and combat information management. This included coordination with radars, weapon systems, and communication links. Today, this philosophy is reflected in modern fighter jets, where artificial intelligence and integrated control systems allow for the simultaneous management of multiple targets and threats. Optimizing real-time decision-making, the YF-23 was not only a design experiment, but also a laboratory for testing human-machine interaction under high-intensity combat conditions. The influence of the YF-23 is not limited to the U.S. Air Force. In international defense circles, the aircraft has been studied to understand how to balance speed, stealth, and control in advanced fighters. Experience with this prototype has fueled debates about what qualities are essential for an air superiority aircraft against emerging threats, including advanced missile systems, quantum radars, and autonomous combat drones. Many experts agree that if the YF-23 concept were modernized with current technology, it could redefine the very notion of air superiority. A recurring theme in speculation about the YF-23 is its possible return in a covert program. Declassified documents suggest that Northrop continued to maintain prototypes in secret hangars and that experimental flights were conducted under classified programs evaluating stealth and new propulsion techniques. Although there is officially no evidence that the YF-23 will return to production, its existence has inspired theories about how it could serve as the basis for a sixth-generation fighter capable of operating in high-intensity conflicts without being detected by advanced air defense systems. The impact of the YF-23 is also evident in the culture of innovation within the aerospace industry. Following the program's closure, Northrop engineers and designers applied the knowledge gained to new developments in high-performance drones and experimental propulsion systems. It is believed that some technologies derived from this fighter influenced prototypes of high-speed unmanned aerial vehicles and advanced stealth research projects. Thus, the YF-23 is not just a historic aircraft. It is a bridge to the next generation of combat aircraft. Finally, the fascination with the YF-23 continues among enthusiasts and experts. Every time images, documents, or testimonies from engineers surface, Interest is rekindled and debates about its true potential compared to the F-22 or F-35 intensify. The story of the YF-23 Black Widow 2 demonstrates that even as a cancelled project, it can offer valuable strategic, technical, and tactical lessons. The aircraft remains a symbol of innovation and audacity, a reminder that the future of military aviation may depend on ideas that, although forgotten for decades, still hold the capacity to change the entire landscape of aerial warfare. Share this video with your aviation fanatic friends and subscribe to discover more shocking stories of military technology and secret fighter jets.